Just about every IoT device I own these days uses or should have used Bluetooth Low Energy. The low power and wireless connectivity make BLE ideal for everything from connected sneakers to smartwatches to foil hats that notify you when aliens are trying to read your thoughts. Wait, is that a real IoT device? But maybe it should be. Let's see. Broadband MIMO antenna embedded above the foil layer, of course, connected to an RF ADC. Kickstarter, here I come! Hi there, I'm Amelia Dalton, host of Chalk Talk. But seriously, if you're going to add BLE to your next design, you might want to talk to the people with just about the most experience in the industry with Bluetooth. In fact, let's talk to one of them right now. My guest is Pratyush Dave from Nordic Semiconductor, and we're going to get into some serious Bluetooth low energy. And before we get started, don't forget to click that link. There you can find out more information about Bluetooth low energy solutions from Nordic Semiconductor. Welcome, Pratyush. Thank you so much for joining me today.
Thank you for having me, Amelia.
Okay, so I know I need Bluetooth LE in my next design to get rid of those pesky cables. Why should I talk to Nordic Semiconductor about my BLE solution?
Well, Nordic is one of the co-inventors of Bluetooth Low Energy. A lot of people don't know this, but back in 2009, Nokia started developing a low-power, low-energy solution that was parallel to the classic Bluetooth that was popular at that time. And they knew that Nordic Semiconductor was a leader in ultra-low power technology. And they approached us, and we, along with Nokia, co-invented Bluetooth Low Energy, which later on was adopted by the SIG.
Very cool. Okay, so it seems like you guys have been in the Bluetooth business for a long time. Is it still going strong?
Yes, we had our first Bluetooth offering in 2011, and by 2014, we had already established a leadership position. And as you can see, by 2016, we had 40% of the market share in Bluetooth low energy only based products. And today, we continue to have that 40% market share.
Wow, that's a lot of market share. Okay, let's get down to some specific solutions. What choices does Nordic offer me on BLE?
Sure. The first standalone system on a chip solution that we released was in 2012. It's the RF52822. And that family of chips started with 256 kilobytes of flash and 16 kilobytes of RAM. And then finally, we had a version that has 256 kilobytes of flash and 32 kilobytes of RAM. In 2015, we then introduced our second generation of Bluetooth low energy system on chip solutions, and that is the NR52 family. And we started with the NR52832, which is the middle of the three solutions that we offer, and it has been our flagship. Ever since we introduced that, it has become extremely popular in the market today. Since then, we have introduced the NR52840 and the NR52810. The NR52810 trims down some of the peripherals that are included in the 52832, and it's a lower cost solution. And the NR52840 adds more features and makes it a more feature-rich solution for IoT, and it's more expensive.
So that gives me several options. How do I decide what to use for a new design?
For the new design, we certainly recommend that you start with the 52 series. And again, now it depends on what you need. If you need features that are middle of the line that can do all the stuff that you need to, and you don't need a lot of memory, the 52832 is the best solution. But if you're looking for a cost-sensitive solution where you do not need all the features and you still have the features of BLE at the same performance, the 52810 is a good choice for you.
Okay, those little gray squares are nice and all, but can we look under the hood of each one of these and find out a little more in detail?
Certainly. So let's start with our flagship product, the NR52832. It's based on an ARM Cortex-M4F processor. The F stands for floating point. So as you can see, having a floating point coprocessor in hardware makes it extremely powerful from a computing standpoint. As far as peripherals go, we have one UART, 3 SPI peripherals, and 2 I2C peripherals, along with 32 general-purpose I/O pins that can be configured to be any digital signal. So the flexibility is there for the hardware designer as well as the software designer to decide which general-purpose I/Os to be configured for what inputs and outputs. Along with that, as you can see, we are an ultra-low power solution. This particular chip has a 5.4 milliamp peak current in the receive and a 5.3 milliamp peak current in the transmit at 0 dBm transmit power, which at the time when we introduced this chip was one of the lowest in the industry. But even today, because of certain features that we have inside this chip, it makes it the lowest power solution in the market today. The NR52832 has 512 kilobytes of flash and 64 kilobytes of RAM. For most of the solutions, that is going to be sufficient memory.
Very cool. And if I need more features or more memory, you said the next one up was the 52840?
That's correct. So we actually got feedback from customers and we listened to that feedback, and that's why we introduced the NRF52840. The 840 has 1 megabyte of flash, so we actually doubled the flash, and 256 kilobytes of RAM, so we quadrupled the RAM. Along with that, we added one more UART. So there are 2 physical UARTs. We added 1 extra PWM peripheral. So there's now 4 PWM peripherals, which makes the 52840 a perfect chip for controlling quadcopters that have 4 rotors. And we also added a full-speed USB 2.0 peripheral and quad SPI, which allows the 840 to execute code from an external flash device. So you can actually expand your memory storage. And finally, we added Bluetooth 5 long-range capability and an additional modulation scheme called 802.15.4. So all in all, you get many extra features with this chip. Oh, and one very important thing, we also added a cryptographic coprocessor. So you can now do a lot of encryption with different encryption algorithms that are popular in the market today in hardware, thereby speeding up your processing in real time.
Great. And so finally, the 52810, that's the lean and mean model, right?
That is correct. So for customers who really want a low-cost solution where they really don't care about having a lot of features, they just need basic BLE connectivity to a smartphone and they do not need a lot of memory, the 52810 is the perfect price point for them. And to make it easy, we made the 52810 pin-for-pin compatible with the NRF52832. So it becomes a drop-in replacement and the customer cuts costs on the overall product.
Great. Okay, so let's say I've picked out one of these chips, and now what tools do you have to help me get my design done?
So we offer a variety of software solutions that will get you on your way very quickly. We have customers who tell us that when they pick our chip and they start with our software solutions, they are up and running in less than 2 days. And in less than a week, they have a prototype that they can show to their management. So what are the software solutions about? So at the base, we provide a Bluetooth Low Energy Protocol stack, which is fully Bluetooth SIG qualified, and it comes as a pre-built binary. So you don't need to worry about how it works. You just use it. We then provide the NR5 SDK, which you use to build a solution, an application that uses our soft device or the protocol stack to make your applications do BLE. Additionally, we have application-specific SDKs that you can use for certain specific applications like IoT and Thread. So as you can see, it's a very comprehensive software solution that quickly allows you to build your user firmware. Let me talk a little bit more about our Bluetooth protocol stack. All the engineers that work and design the Bluetooth protocol stack are employees of Nordic. So the development is completely done in-house. So we have full control over our development. If there's any bugs that are found and reported by customers, or if there's new features that come out from the SIG, we are able to quickly implement the features, test them, do an alpha release, make sure we are fully qualified, and then do a production release. And this entire cycle takes less than 3 months, and we can come out with a new feature.
Wow. Okay. Earlier you mentioned you support Bluetooth 5. So tell me, what is that all about?
So in December of 2016, the Bluetooth SIG adopted the standard called Bluetooth 5. The standard has 3 major features. The first one is where it doubles the speed and thereby lowers the power. So now you can actually transmit the same BLE data in half the time over the air and thereby get twice the throughput. The second big feature is Bluetooth long range mode. So there's 2 data rates, 125 kilobits per second and 500 kilobits per second, and those are supported by the NRF52840. And by adding the long range feature, Bluetooth 5 now provides full house coverage. The third major feature is a high throughput broadcast, or what's called advertising extension, that allows users who really do not want to connect to a smartphone but only to transmit lots of information and data to the other end, do that quickly and efficiently. And we support Bluetooth 5 fully. High speed and the advertising extension features are supported by all three of our 52 family devices that we just talked about. It's only the long range that is supported by the 52840 uniquely.
Okay, and what exactly makes these chips Bluetooth 5 ready?
So what we did is, as soon as the Bluetooth SIG came up with the standard, shortly after that we released the S132 Bluetooth Low Energy Protocol Stack with the Bluetooth 5 features supported in it. And for the 52840, we released the S140 Protocol Stack, which supports the long range in addition to the other two features.
Okay, so you said a little bit ago that the range was better with Bluetooth 5. How much better?
So, as far as radio frequency technology, you cannot just quantify range in terms of meters. It's always going to be approximate. So the way it is done is there's something called a link budget that decides how big your range is going to be. Of course, range is also dependent on interference from solid objects in the way. And that's why the link budget is the most important number. So with the NR51, when we released that chip, our total link budget was 97 dBm. When we introduced the NR52832 back in 2015, we increased the receiver sensitivity, which led to a total link budget of 100 dBm. So as you can see, it went up by 3 dBm. And in RF, every increase of 6 dB in the link budget doubles the range. So going from the 51 to 52, the range went up a little bit, not quite double. Then we introduced the 52840, which has a plus 8 dBm transmit power capability built in, which then leads to a 104 dBm link budget, thereby doubling the range from the NR51. And then the low power mode of 500, and then the link budget gets increased because of the decreased data rate. So in Bluetooth 5 long range, with a 500 kilobit per second data rate, the link budget goes to 107. And with the 125 kilobit per second data rate, the link budget goes to 111. So basically, you can see that the range from the NRF52832 at 1 megabit per second Bluetooth mode, the range goes up 4 times. And that's how you get the long range.
And you said that throughput was better too, right?
Right. So the SIG has been releasing features that have been enabling the additional throughput. And we have kept up with that technology in our Bluetooth Low Energy Protocol stacks. So with the NR51 and the initial release of the 52832, we were at a 124 kilobits per second throughput, which was the maximum throughput achievable in a BLE link. As you can see, when we implemented the Bluetooth 4.2 features, that went up to 150 kilobits per second and eventually to 800 kilobits per second. With the advent of Bluetooth 5, we came up with the S140 and the S132 protocol stacks, and they can now achieve up to 1.4 megabits per second.
Okay, wow, that's impressive. Okay, so I'd like to understand more about the SDK you mentioned earlier. Can we dive into that a little bit?
Absolutely. So obviously, here's our chip with a lot of peripherals inside and a lot of features. How can a developer be able to capitalize on those features and quickly get them into their application? That's where our NR5 SDK comes in. We offer a single unified SDK that can support both the NR52 and the NR51 series of chips. Each SDK has hundreds of modules inside that take care of the peripheral drivers, and we also provide many examples for a variety of applications. So the customer is always going to find some example that they can use as a starting point, thereby shortening their overall development cycle. And finally, the SDK is packed with the hardware abstraction layer drivers for all of the peripherals that are in our chips. There are some more details here of what the SDK provides. All the features, the SDK provides all the Bluetooth low energy profiles and services that have been adapted by the SIG today. We include them in full source code format for the users to use in the application. Of course, we have the NFC feature that we will talk about in a short while. We support the NFC feature in our SDK along with all the examples that I talked about earlier.
Now, one of the issues with Bluetooth is always pairing. It's a pain for edge devices to pair and do that securely. So how do we handle that?
So that's where the NFC comes in, which I just mentioned. So NFC stands for Near Field Communication. And basically, it's a little coil antenna that needs to be attached to the RF52832 or the RF52840. And when a smartphone or any other NFC reader is brought close to this coil antenna, it energizes the NFC tag inside the RF52832 or the 52840, and thereby it enables the tag to be read by the reader. Where this really comes into handy is what we call out-of-band pairing. And that's where NFC is being used, and that's the main implementation in our NR52 series. The out-of-band pairing makes it very easy for even a non-technical user to take the smartphone and tap it to the device, and the device would be paired to the application running on the smartphone.
So to use this, I only need an NFC tag for my device then, right?
That is correct. And we support two different NFC tag types, tag type 2 and tag type 4. Tag type 2 is the one I just described that can be used for touch-to-pair type applications. Another example of tag type 2 is when the reader comes close to the NFC tag, which is of type 2, it can transmit to the reader our URL, and the reader's smartphone can directly go to that website. Another example of tag type 2. Tag type 4 is very important. It is used in the payments. So the NR52840 and the 52832 can be implemented into a payment type device, which when you bring close to a reader and you tap on it, you are able to make a payment.
Okay, this sounds great for my design, but once my product is in the field, I have to deal with firmware updates, which can be really tricky on edge-type devices. So how do we handle updates?
Good question. And I'll tell you, this is one feature that we have in our chip that I believe has led to us being the market leader today. The entire application memory on the chip is flash-based, and that's what allows people to upgrade to a new firmware. It's just like your smartphones. When Apple has a new update, it gets pushed onto your phone. Well, we provide the infrastructure for that. We provide what's called a device firmware upgrade feature, which includes a bootloader that's included in our SDKs. And with that bootloader, and with a mobile app running on a smartphone, which, by the way, we provide examples of, the user can do an over-the-air device firmware upgrade of their application while in the field. So, if you have application that has been deployed in many devices being used by customers, and you want to add a new feature, or there's a bug fix, it's very easy to roll out that update. And we have lots of customers today who do exactly that. What's more, the DFU makes it even easier for the device to update to a new protocol stack when we roll out new features in our new protocol stacks, thereby making the device in the field not obsolete, but making them future-proof, just because of this firmware update feature. One additional thing I would like to mention, because security is very important, we actually offer and support a secure over-the-air device firmware upgrade today. That security ensures that no rogue person or device can upload a bad firmware and break your device or make it useless.
That sounds great. Now, you mentioned earlier that you have application-specific SDKs. I'm doing an IoT design. Would this help me?
Yes, specifically for people and to support the IoT, which is, by the way, something that the future is going towards. We have a NR52 SDK for IoT. It's a complete Internet Protocol suite for the NR52 series SoCs. Everything is based on an open standard, which is the good part. So there is nothing proprietary in our IoT SDK. IPv6 addressing is included, commissioning to the router solution is included, and we of course have the OTA DFU that we just talked about that is available. And what we have done to make it even easier for our customers to implement IoT type solutions is that just most recently we released our SDK version 14.1 last month. We merged the IoT SDK with the mainstream SDK. So instead of now the user having to download two different SDKs and having to work with them, they can work with one SDK and get the IoT solution implemented.
Okay, so earlier you mentioned Thread. Can we talk about how Thread comes into play here?
Sure. So Nordic Semiconductor is a member of the Open Thread Alliance, which was started by Google, and we'll talk about a little more of that in a bit. What we did is when we designed our RF52840 radio, we decided to add one more modulation scheme, which is the IEEE802.15.4. That's the modulation scheme that is used by the Open Thread Alliance and Thread Protocol. So what we have that enables a customer to implement Thread is the NR52840 chip, the NR5 SDK for Thread, and the NRF Connect tool that helps debug the Thread application.
So what's Open Thread all about?
So Open Thread project was initiated by Google Nest to enable IoT type applications for inside the house. It's basically a personal area network based on the 802.15.4 protocol. OpenThread is an open source implementation of the Thread protocol, which can use both IPv6 and IPv4. And Nordic actively contributes to OpenThread today. The current version of OpenThread is 1.1, which is what we have implemented in our solution.
Okay, so do you have an SDK for Thread as well?
Yes, the NR5 SDK for Thread is available today in the alpha release. The production release is going to be in the first quarter of 2018. And the key features for this SDK are that we have a complete pre-built Open Thread stack for the NR52840 that's included in the SDK. So all you do is you program that stack in the flash and start developing your Thread applications on top of it.
Now, if I don't care about using Thread, do you have a solution if I want to directly use the 802.15.4 MAC layer?
Yes, absolutely. And that's actually very important because the 802.15.4 has been around since 2006. And it is also popularly used by Zigbee. And Zigbee is a very popular 2.4 gigahertz protocol, as you know. Unfortunately, Zigbee is not low power. And of course, the smartphones don't have Zigbee. So the implementation of Zigbee is limited to where you do not have a smartphone, but you have a specific gateway to do the job of a smartphone. Coming back to your question though, we provide a complete 802.15.4 MAC layer implementation that is available today for you to download. And instead of the SDK for IoT, you can use the MAC layer and provide your own protocol on top of it that uses 802.15.4. So you have full flexibility to go either with SDK for Thread and do a Thread-based application or do your own custom application using our 802.15.4 MAC layer implementation.
Got it. Now, I've heard that Bluetooth SIG has released a mesh standard. Do you support that?
Yes, as you know, we are closely tied in with the SIG. So as soon as the mesh SDK was adopted by the Bluetooth SIG, we came out with our SDK for mesh, the alpha release of it. And as you can see, the architecture we support is exactly the architecture that has been adopted as a standard for mesh.
What does one of these mesh networks look like and how does it work?
So basically, the mesh network consists of many BLE nodes, and the nodes can be of different types. But together, the whole idea is that any message or data that is sent out by one node gets propagated throughout the mesh network with a minimum of latency to get to the end node. And the type of nodes are, there's a relay node, basically. Any node can be a relay node. Then you have the end node that basically all it does is generates the data, but doesn't relay it. So it relies on the relay nodes to relay the data throughout the network. And then there's something called low power nodes because as you can see in a typical mesh network, the relay nodes need to be on all the time. They have to be listening for the data and passing it on. So they are receiving and transmitting all the time. So they cannot be low power. So there's low power nodes that have been specifically defined which can still be operated on a battery. The low power nodes although require what's called a friend node. So that when they do wake up, the friend node will have data that it cached, which really was meant for the low power node. And that's how the mesh network works.
And what other SDKs have you got for me? You said there were several?
So the other important one is that Apple came out with their IoT solution, if you want to call it that, a few years ago called the HomeKit. And of course, Nordic decided to make a HomeKit SDK. And today our HomeKit SDK provides an excellent solution for customers who want to implement HomeKit-ready appliances and devices.
Okay, I'm ready to get started designing with my Bluetooth LE. What kind of kits and tools have you got for me?
Okay. Nordic provides a variety of tools and development kits that can help you as a designer get started very quickly along with our SDK tools to come up with a nice solution. We provide development kits for the NR51 series, and in the NR52 series chips, we provide the development kits for NR52832 and the NR52840. Because the NR52810 is a subset of the 52832, customers can use the same development kit as for the 52832 to develop solutions for the 52810. Along with the development kits, we actually provide a few reference designs, and we'll talk about that in a bit, but we also provide a lot of PC and mobile tools. The NRF Connect is one of them that actually runs on either a Linux or Windows or a Mac OS platform. We also have our own NRF command line tools, also running on all these three platforms. We provide an NRF sniffer that is very useful for debugging over-the-air BLE traffic.
Okay, can we dive into some of these kits and stuff in more detail?
Sure. So here's a reference design that has become extremely popular. We released this design earlier this year in the form of a product that can be purchased from our distributors. We call it the Nordic Thingy 52 because it is based on the NR52832. It's basically a reference design for a lot of sensors that are being supported by the 52832. And the data that is being read from the sensors is transmitted over BLE to a smartphone app. It's the Nordic Thingy app, which is available to download for both the Android and the iOS from the app stores for free. This reference design really helps customers who are looking at doing a sensor fusion type design that requires several sensors to be integrated with the NR52832 for their end product to get a real good head start using this reference design.
So one of the reasons I use BLE in the first place is my designs tend to be really power sensitive. Can you help me measure and optimize my power?
Certainly. That's one of the things that we call the Power Profiler Kit, and we released that early this year as well. And ever since its release, it has become very popular. Not only can you power profile an application running on the NR51 or 52 device, but you can power profile any application running on another MCU, and that is really helping customers not only to optimize their own solution, but sometimes to do a comparison of their solution running on our chips versus our competitors' chips and seeing where they get the better power consumption.
That's a really good tip for comparison.
Yes.
Okay, so I get my design going, but how do I know that my BLE software hardware is going to work correctly with all the devices I'm pairing it to?
For that, we offer a multi-platform tool that I alluded to earlier called the NRF Connect. The current version of the tool is 2.2. The tool is free to download from our website. It runs on Windows, it runs on Linux, it runs on Mac OS X. And what's good about this tool is the NRF Connect application running on your PC along with the NR52 development kit hooked up to the PC with a micro USB cable becomes a BLE central solution to which the user can pair their device over the air, over BLE. When that is done, the NRF Connect actually will show the user the BLE services and characteristics that they have implemented so they can see visually whether they did the right thing or not. Then, next, the NRF Connect tool allows the user to exercise each individual characteristic in the BLE services, thereby letting them see if the correct behavior is being executed by the device based on the data that they can send manually through the NRF Connect tool. So that way, in that fashion, it allows the user to step-by-step debug their BLE application. The NRF Connect tool is so powerful and is also available for both the Android and iOS that our competitors actually download and use that tool in their applications.
Ha, that's funny. Now, one of my challenges is on the mobile app side. Do you have any mobile apps that I can use to test out my solution? Because I don't really want to have to build a mobile app from scratch.
Yes, so we started off with the NRF Toolbox. That has since become a very popular mobile app. And what the NRF Toolbox does is it takes the standard Bluetooth SIG adapted profiles like the heart rate service, the blood pressure monitor service, the glucose service, and implements them on the app side for both iOS and Android. Along with that, we have now got many other tools, including the NRF Connect for Android and iOS, the NRF Beacon for Eddystone, which, by the way, is a Google format for Beacon to compete with the iBeacon format from Apple. So for each of these mobile apps, we provide the full source code with the exception of a couple of them. Having source code really helps our customers use that as a starting point for their project and their mobile apps.
Okay, so what's coming along in the future? Anything cool on the horizon that we should be aware of?
Yes. So we have talked about Bluetooth Low Energy. And you know what it solves is it allows you to form a personal area network which is fully wireless up to 100-meter range. What about going beyond 100 meters? What about going to the cloud? Obviously, with Bluetooth Low Energy in the house, you would need some sort of a gateway or router that eventually connects you to Wi-Fi or cellular infrastructure, and you can then get to the cloud. Well, Nordic has already announced that we are going to be coming out sometime towards the end of 2018 with a LTE-M solution. So the M stands for mobile, and LTE-M is an IoT solution. It basically incorporates much lower data rates than your standard cellular LTE solution, but allows you to have data connectivity to the cell tower, thereby enabling a gateway to the cloud from your personal area network.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia. It was a pleasure talking with you.
And before we go, you didn't forget to click that link, did you? There you can find out more information about Bluetooth Low Energy solutions from Nordic Semiconductor. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal or check out YouTube, keyword EE Journal.